In Chapter 11.6, we're going to learn about conditional probability. So in this section, you will learn how to calculate conditional probability, and you will learn how to calculate probabilities in a contingency table. In general, the probability of event E2 occurring, given that event 1 has happened or will happen, the time relationship does not matter, is called a conditional probability and is written as the probability of event 2 given event 1 has occurred. So our first example is a single card is selected from a deck of cards. Determine the probability that it is a club given that it is black. Well, the card is black, so only 26 cards are possible, 13 of which are clubs. Therefore, given that the card is black, what is the probability of a club is equal to 13 divided by 26, which is 1/2. For any two events, E1 and E2, the conditional probability of E2, or event 2, given E1, is determined as the following. The probability of event 2, given event 1 has occurred, is equal to the number of outcomes that have event 1 and event 2 together, divided by the number of outcomes in event 1. So now we're going to go ahead and use the following idea of conditional probability. 250 patients had knee, hip, or heart surgery, were asked whether they were satisfied, dissatisfied, neutral regarding the results of their surgery. The responses are given in the table on the next slide. So this is what we call a contingency table, and in fact we see that it is broken up into two variables, both of which are in some ways qualitative. In other words, they don't have numbers associated with them. So I could either be satisfied or dissatisfied with my surgery, and the types of surgeries I have is knee, hip, or heart. And you can see that it goes on the rows is the surgery type, and in the columns is whether it's satisfied or dissatisfied. So the question is, if one person from the 250 patients surveyed is selected at random, determine that the probability that the person was satisfied with the results of the surgery. So if they're satisfied with the results of the surgery, that's part A, we see that the total number of individuals that are satisfied here are 205 out of the 250 patients. So the probability of satisfied is 205 divided by 250, which is equal to 41 out of 50. Part B says, what is the probability of a hip surgery? Well, the probability of a hip surgery in this case, and we will write it, probability of hip is equal to 105 divided by 250. Is that what you got? Well, that's the answer, right? And you can reduce this if you wish to do so. The idea here is the total number of hip surgeries was 105 out of the 250 patients. The next question was, what's the probability that the randomly selected patient was satisfied with the results of the surgery given that the person had knee surgery. So given that folks had knee surgery, you can see that there's 95 patients there. And now that was satisfied, and had knee surgery is 70 divided by 95. And if we reduce it, we end up getting 70 over 95, which equals 14 divided by 19. Again, if we use our calculators, we can get this in decimal form. So we can use the conditional probability formula again. And the question now, part D, was, given we select a patient at random, what is the probability that the patient was dissatisfied with the results of the surgery given the person had hip surgery? Well, in this particular case, the probability of having a hip surgery, or the number of folks that had a hip surgery, was 105. The number of patients that were dissatisfied, in this case both dissatisfied and had hip, was 15. So it's 15 divided by 105, which is 1 divided by 7. The last question says, what's the probability of a randomly selected patient had heart surgery given that the person was dissatisfied with the results of the surgery? So now we're looking at given is either a column or a row. In this case, the given was dissatisfied, so that's always in the numerator. And so we had 45 patients that were dissatisfied out of the survey. But of those, only 5 that were dissatisfied also had heart surgery. So that ends up being 5 divided by 45, or 1 out of 9 patients that was dissatisfied had heart surgery. So in summary, in Chapter 11.6, we understood the idea of conditional probability. We understood the formula of probability of the given statement. And we were able to calculate probabilities in a table, and we know when to use conditional probabilities. So that concludes Chapter 11 in probability that we're going to cover this semester. We will be starting, after our exam, statistics.